start by introducing the team. Craig, Susan, Sheraz, and Suresh. And my name is Dave. So I'm here to talk to you today about a problem that we found in developing a project here at Gloco. Healthcare reform is pressuring healthcare providers to deliver more cost-effective care. At the same time, we're expecting the sales of new ultrasound machine equipment to diminish as providers start really keeping their current equipment longer. So our opportunity is to provide a premium service plan for new ultrasound machines. Our goal is to grow Gloco's revenue by 4%, and we're going to do that by selling premium support plans to 30% of all our new sales. And we're hoping that this is going to be a really good product that's going to help us capture a larger market share in the industry. The business benefits are increased revenue, less time and money spent by support staff fixing these incidents, and we're going to be providing some business intelligence tools to help us support decisions. Our healthcare provider is going to see increased uptime and decreased risk. There's going to be automatic monitoring of machine usage, and this will help with their accreditation of equipment. To tell you a bit more about the use case, I'll turn it over to Craig.
Okay, so for the next 5 slides, I'm going to show you the use cases to kind of give you an idea of the benefits of the project. And over those 5 slides, we're going to go through 3 use cases. In this first use case, we have the healthcare provider in lane 1, and then we have Gloco in lane 2. What's going on in this use case is we have some failure on the machine, or we have some scheduled routine service that needs to occur. And so what will happen is the service technician will contact Gloco after they've noticed the failure. That might take 1 to 2 days. And once they notify us, then Gloco will send out their support rep and diagnose the machine. And they may determine that there needs to be a new part. If they have to order a part, that will take a couple of days to get the new part. And so we're talking about 5 days in the current situation. The to-be, we have the Gloco ultrasound machine at the healthcare provider automatically sending the data to Gloco, and the support rep is alarmed and notices right away that there is failure. They can order the parts if needed, but that's all happening in day 1. So we cut out 2 days, and so the total time in the to-be is going to be about 3 days. So we cut out 2 days with the automation. In use case 2, we're talking about the reporting and analyzing the data in the ultrasound machine. What's happening right now at some of our major hospitals is it takes about 8 days for a healthcare provider tech to go to each of the machines, grab the data, put it on the thumb drive, bring it into an Excel spreadsheet, and crunch it, and then present that to the manager. So it's about a 10 in the current as is. The to-be, the ultrasound machines are talking to the cloud, sending the data to the cloud, and that data becomes immediately available to the healthcare provider manager and to the Gloco system analyst through the dashboard. In the final use case, we have no as-is. This is something that we're going to be able to offer in the future that we can't do today, and that's simply the ultrasound machines are going to be logging data to the cloud, and we can watch in the cloud. We can see how many hours each ultrasound machine has been up. And after a certain number of hours, we can trigger an alarm to send somebody out to go service that machine. And now I'll turn it over to Susan to talk about requirements and high-level architecture.
Thank you, Craig. So we've identified some required functionality for this solution. We need to set up ultrasound machines so that they can send alerts and regular log files to a cloud-based database. We need to integrate that cloud-based database with the customer relationship management system at Gloco and other Gloco databases. We need to automate alerts, trouble tickets, and job assignments. We need to create and integrate dashboards into an existing customer self-service portal, which is available to healthcare providers. And we need to develop dashboards to serve as decision and analysis tools for Gloco personnel. So this is a very broad overview of our solution. We're highlighting one of 2 main parts of the solution. This part is the MedListener application. You can see that it runs at 3 different sites. We have the healthcare provider on the left, the computing cloud in the center, and Gloco over here to the right. So this illustrates a simple example. We have at number 1, we have the ultrasound machine issuing an alert to the MedListener application. The MedListener application uses the machine and customer information to get information from the Gloco database and also to create a trouble ticket automatically within the CRM. And the CRM sends back the trouble ticket to the MedListener application, which places it in the MedListener database to be used later as a key into the CRM. OmniDash is our dashboard solution. Here we have nightly managed file transfer going into the OmniDash database. And when at number 2, when a request for information comes through, the data is pulled from the MedListener database, from the existing OmniDash database, and also some customer and service data can come from the Gloco databases to provide the view of the analytical data for either the people at the healthcare provider or at Gloco. So I'll now turn it over to Sheraz for some information about our hardware and software choices for the solution.
Thank you, Susan. So TeamOne Solutions decided to go with a cloud-based infrastructure. One of the main benefits of the cloud is it's low cost. So there's no upfront hardware cost, there's no setup or maintenance of hardware. There are no licenses you need to buy upfront. So basically all that boils down to very low upfront startup cost, which is good for our project. It also is a pay-as-you-go service, so you don't have servers just sitting there idle with a large infrastructure internally. You actually just pay for what you use. So as we sign up more and more customers, we'll ramp up our resources and just pay on an incremental basis. So we can dynamically scale for load. We can scale for as many customers as we sign as quickly as needed. Gloco is also a worldwide company. So the cloud allows us to provide our solution worldwide and also provides the reliability in case one zone goes down. Since it's a worldwide based infrastructure, we have another zone up. So we looked at 2 of the major cloud solutions in the market today, which are Microsoft Azure and Amazon Web Services. Microsoft Azure is mostly tied to .NET, and Gloco's enterprise systems presently are not fully .NET. And most of the benefits of Azure come from a .NET-based solution. So for us, Amazon Web Services was the obvious choice because it provides the same competitive features and competitive pricing as Microsoft Azure, but is software agnostic and doesn't require a lock-in to .NET. Amazon Web Services also provides a service level agreement of 99.95% uptime. Given the way we've architected our solution, the machines will actually save data if the connection ever goes down. So we have a fallback plan, and this SLA is more than adequate for our needs, so we don't need to go for a more expensive solution that provides a higher SLA. For our dashboard software for Tableau, for our OmniDash solution, we considered a number of companies. We ended up deciding on Tableau because it's easy to integrate with multiple sources. It's web-based, so it requires no additional software at the client side. It has extensive security capabilities, so each healthcare provider only sees their own machines, but Gloco, we can see all the machines. It's also scalable in the cloud, allowing us to ramp up because we have a cloud-based solution. Now I would like to invite Craig and Suresh to discuss the technical architecture.
Thanks, Sheraz. I'm going to talk about the technical architecture we are using for this solution. It's primarily broken into three sections. The first one is the healthcare provider. The second one is the Amazon Web Services. And the third one is the Gloco Enterprise one. So here, at the healthcare provider, the ultrasound machines are capable of sending a file or an alarm when there is an issue. Through the communication capabilities, either with Wi-Fi or Ethernet card, it can send a file to the application server. The application server is configured with the Amazon credentials, so you can talk directly to the Amazon cloud. So application server is going to push the path to the S3. It's a simple storage service bucket, where the path will be sending to the file repository. It's a S3 bucket. And the mechanism which is residing on the application layer is going to be constantly looking at the S3 bucket to see if there's a new file, and it's going to process that, and it's going to send it into the mechanism database. While doing the process, if there is an issue, if there is an error, it automatically communicates with the enterprise interface bus to Gloco CRM to raise a ticket, to sending the information like the mission information, the customer information, and what is the error, and it's going to create a ticket on CRM. And while creating, the response will be coming back as a service ticket. So the database will be tied with the service ticket back to the system, and the Omni dashboard at the top level, what you're saying, that's going to use the Tableau server, Tableau repository, where the data is crunched from the manager. All the time it's going to keep on adding to the repository. So the Omni dashboard is purely relying on the Tableau repository data. And on the issues, every issue has a URL which is pointing to the Siebel CRM portal. So if there's an error, someone wants to see what is the error and who is the technician, how it is going, they can directly go to the Siebel CRM portal to view the complete details. So this is the whole architecture for the application, for the solution we provide. And I'm going to give it to Craig for the integration.
Thanks, Suresh. Okay, so this shows on the premium service plan the integration between the healthcare provider's ultrasound machine all the way down to the Gloco web client. We have several layers here. In the green is the healthcare provider's ultrasound machine. In the yellow, we have the Amazon cloud layers. And then we have in the pink, I guess that is, the Gloco layers. So the ultrasound machine is communicating to our application servers, the EC2 servers that Amazon provides. And that data is going to be stored in their database, which is the next layer. And then finally, the last layer is the Amazon queuing service that will communicate across the internet into our Tableau instance in Gloco. The Tableau instance in Gloco is going to be, the TIBCO instance in Gloco is going to be communicating and sending that data into our CRM systems. Our Siebel CRM, Siebel self-service portal, and then our sales and merchandising system. That simply ends there. Then you can see down here that we have the Tableau dashboard for visualization inside of Gloco that's fed from the reporting service out of the Amazon cloud.
Thanks. I'm going to talk about the project teams. Actually, we have two project teams. One is at the healthcare provider level. It's a small team with a manager and IT support and technician to look after the application server and maintenance of the ultrasound machine. At the same time, like configuring the ultrasound machines to send out the files to the application server. And the second team is at Gloco. It's a project team which is probably developing the Omni dashboard and the management application. So here we have and business analysts and architects who are reporting to the project manager. And there's an Amazon architect who will be working closely with the software developer and the Gloco CRM architect and the Gloco CRM software engineer to come up to build the management application. And the dashboard developer and the report analyst, business analyst will be working on the Omni dashboard application. And the last component to the right, where the service team, the help desk person will be responsible for assigning the tickets to the service technicians. And we'll give it to Craig in the project, please.
Okay, so the project to implement this premium service plan will take us about 18 months. We're talking about a year to develop and then about 6 months to run a beta. So we're going to try to select a customer and maybe give them a discount or even free software. So that's going to happen a little bit earlier than by January we'll be able to implement this beta. So if we look at the timeline, we're talking about starting in January, this next January. And for about 3 months, we'll be gathering requirements, trying to get the primary architectural diagrams done. And then for the next several months, we're going to be trying to get a beta site selected, get the software installed on one of the ultrasound machines. And what we're going to do here is we're going to try and get the training going early. So we have, during this third phase here, we have the training of service techs, we have the actually knowledge transfer starts in October, and then we're going to carry that knowledge transfer into the beta for several weeks, make sure that we do a really good handoff to the support reps. 6 months beta, and then we're hoping to be done by June 2014. And I'm going to turn it over to Sheraz to talk about user enablement.
Thank you, Craig. So one of the toughest challenges during any IT project is how to enable the users during their transition. One of the major benefits of our plan is that it provides major benefits with minimal changes at the healthcare provider. So a lot of the stuff is done using automation in the background. So the user actually doesn't see anything and doesn't have to do anything to get the benefits we offer. So tickets, information is automatically gathered by the ultrasound machines and sent to the cloud on an hourly basis. Alerts are automatically logged and sent real time to the cloud, along with all relevant information about the alert. The ticket is created in the Gloco CRM, and it can be resolved faster because it has all the information Gloco requires to fix the ultrasound machine. And all this happens without the user having to do anything, actually. So a lot of benefits are provided, very minimal changes. In fact, there'll be some process changes, but the user's life is actually made easier. We will also provide the ability to automate several paper-based manual processes currently associated with ultrasound machines at a healthcare provider. So basically the maintenance of the ultrasound machine, the certification of it, the replacement of it. We will enable the healthcare provider to actually automate these paper-based processes, but it's an optional product. They don't need to use this piece to get the benefits of the premium service plan. So to facilitate the user adoption, we're going to be conducting user surveys. We're going to model the user interface on existing paper forms just to make it so that the transition for the user is easier. We'll be providing training and documentation. We will also allow the software user interface to be customized so that each healthcare provider can cater it to their own personal needs. We will also deploy automation wherever possible, so a lot of the benefits happen in the background and the user's life is actually made easier in the process. As Craig mentioned, we have a 6-month beta period. During this time, we're actually going to be fixing bugs, looking at the software as to how it works at the healthcare provider side, taking surveys, basically making sure that we offer a better product when we actually go to market at the end of the beta period. This will help mitigate the risk and allow us to offer a much better product because it's actually been vetted at a healthcare provider side. I would now like to pass it on to Susan to discuss risks.
I'll just hit the highlights with the risks. One of the major risks that we've identified is schedule overrun. And to mitigate this risk, we plan on having an advisory board of upper management at Gloco that will meet with the development team monthly and will receive weekly status reports from the development team. We also are going to institute a bonus pool for completing the work on time. User rejection is also one of our high risks. We plan to form a steering committee of the people at Gloco who are most heavily impacted by this solution, and that will also meet monthly. I'm going to turn it over now to Dave for some talk about metrics we use to measure the success of the program.
So for metrics, our number one goal is obviously to increase revenue. And our goal is to increase revenue by 4%, and again, that was by selling the service plans at a rate of 30% for new machines. And we're also focusing on ultrasound machine downtime, the reduction in the repair costs, service call resolution time, and obviously customer satisfaction. We think this is going to be a good product that our customers are going to enjoy. And lastly, with a few minutes left, and we're running towards the end of our time here, we have a brief demonstration of the product in action.
So the team chose Tableau as our dashboard and visualization software. I'm just going to walk you through a couple of dashboards that we created with Tableau for the ultrasound machines. What we're looking at here is our preventive maintenance dashboard. And what we're doing is we're taking all those values that the ultrasound machines are sending us, things like fan speed, diagnostic information, and we're really using to determine the health of that ultrasound machine and when we need to dispatch a technician. A 1.0 means that we need to send somebody out to look at it. This is a flexible number. So what we're doing is performing just-in-time maintenance, and really anywhere between, say, a 0.8 and a 1.2 is when we want to take a look at the ultrasound machine and make sure it's up and running. And this tool lets us look and see a picture of really the health of the entire network. So these filters at the bottom let us go and change things around. So let's only look at the machines that really need it. So let's say 0.84 and up. As you can see, the map is adjusting as well as the bars here. Let's go a little further. Let's only look at the West Coast. Let's even further. And let's look at Boise. And these are the three machines that we want our technician to look at. So we've got the machine ID and their values. We've got a 1.2, got a 1.13, and a 0.98. So those are the three that our technician wanted to be dispatched and take a look at, perform the routine maintenance on. But what happens with this actual problem? Our machines call home, and as we mentioned, we have a failure in one of our machines. And one that we're going to look at is the one at Red Couch MRI. Let's just go ahead and dial down, just show Red Couch in this screen. And here's the problem. We have a failed cooling fan, and our technician has already been assigned. We have the contact information, the ticket number. If we mouse over, we see the address, the trouble ticket number, the machine ID. And if we click on that, we'll be brought to our trouble ticketing system where we found that a ticket has already been created. We have the error code, we have the error description, and also the replacement part, which is rather handy. And the machine itself called it in, so without any interaction between any people, a ticket has been sent, and we're ready to go. We're ready to dispatch our technician. That's it.
Yeah, there are a little overtime, so try to finish up the other end or so.
We're done.